Welcome to this week's tutorial slash lecture video. Today we're going to be talking about really a quite universal thing in engineering, which is graphical communication. We need graphics to communicate both conceptual things, sort of an idea, a process, a flowchart maybe, as well as more technical things, which may be a physical object. Quite often, particularly people like mechanical engineers or civil engineers, need to represent a three-dimensional object, very big, like a bridge, very small, like a particular bracket. Represent those three-dimensional objects as accurately and informationally dense as possible in two dimensions on a screen or a page. To do so is a fine art. We can use things like an isometric view, as shown here for this sample bracket, which requires a little bit of artistic skill, drawing things in perspective, but it doesn't necessarily do the best at conveying different dimensions as clearly as an alternative set of views. Today, we're going to be working on sort of turning this isometric view into the orthographic projections or the orthographic drawings that is showing from each different dimension head on. So we're going to show what this part looks like from the top, what it looks like from the front, and what it looks like from the side. Three-dimensional objects, three different drawings at least to show off what shape this part is, what the precise dimensions of each feature might be. We're using this program called Inkscape. Inkscape is a free to use program. One reason why we're using it here is I don't want to force you to buy any software. So we're going to use this one uh, to get started. There are other ones out there, and there are ones that you may use more professionally later on, but they also have the same idea of rendering these vector-based graphics, ones that scale very well, aren't limited by resolution or sort of pixels. For each of these, anytime you use a program, I always suggest you do a little bit of a tutorial. So you'll want to, on your own time, look through these set of three tutorials, basic, shapes, and advanced, to get an idea of what this program can do. Again, we use this both for technical drawings, but you can also use this to create logos or pictures or other graphic design elements. So a very useful skill to have. For our video here, we'll dive right into trying to use this program to generate these images. We'll sort of fast forward through the parts in which I'm just trying to align things, but we'll sort of stop along the way and hit the key highlights of features and functions. Before we begin, I do suggest you do a couple things to your workspace. One, I would turn off this option that scales the stroke width, so the line width with the size of the object. For these technical drawings, I do generally recommend that you keep the same size and shape of your stroke width just for clarity. So I'll turn that off. I would also turn on and enable snapping, which helps you align to different features of your image, aligning to the corners or the centers or sort of uh, key points along your object. I would turn this on to make your work a lot easier and a lot more precise. So Inkscape has a lot of different features, and you'll take some time. I suggest you take some time to explore a little bit of what it can do. The main thing that we're going to be using is to generate polygon, so different sort of polygons, squares being sort of the main one, circles, as well as text annotation, of course, is very useful. The only sort of fancy advanced tool that I would suggest you use would be to use this ruler tool or measuring tool. Now, this graphic is not terribly precise. It's not necessarily drawn to scale, and in perspective, it might be hard to get a few different features. But we can still use it to get a general idea of what shape and what dimensions each of these parts should have. So we're going to first try to get an idea of how big this seat of this sort of bracket-looking, chair-looking bracket is. And I can see, if I zoom to scroll a little bit to the side, that across the diagonal, the hypotenuse of this triangular section, or sort of the seat, reads about 70 millimeters. You'll do some math and you'll realize that that means each of these sides of sort of the seat of this chair-shaped bracket should be about 50 millimeters or so. You can also measure some other features. So I would say that if one side length in this perspective is about 37, I can also get the size of the back of this chair as well. So looking at that, about 37 or 40, I see that the back reads about 8.5 or so. So about 1/5 of that seat width is going to be the width of that back. So you don't have to be terribly precise. You don't have to have a specific value, of course, since we're not given one here. But to help us and make our drawing a little more visually appealing, we're going to set those to be 50 and 10 millimeters respectively. So we're going to drag and drop a square to begin forming the shape, the outline of this top-down view. And there's a couple of things we want to pay attention to here in Inkscape. We set a stroke width or stroke style, and that is the line outer border of this object is the stroke. The fill would be the color. That fills a solid object, but we're going to keep a line drawing for now. We'll set the width to be 1 millimeter or so. Something to be very mindful is that if we were to specify and type in that the dimensions of this box should be 50 by 50 millimeters, what this dimension refers to is the outer perimeter, not the center of the line. We'll see what that means more dramatically. Let's say if I were to change this to be a 10 millimeter by 10 millimeter box. So readjust that to say 50 and 50 once again. And if I was to measure what these actual dimensions are, I would see that the outer perimeter is going to be 50 millimeters versus what I actually want to be representing would be sort of the center point of this line, which here, oops, if I was to anchor towards the individual corners there, I would see is only 40 millimeters. So essentially the width minus the line width or the stroke width. So in doing so, one thing I have to do here in Inkscape and a lot of drafting programs is to be mindful of that and to set my units accordingly. So if I wanted this to be a 50 by 50 millimeter drawing with a 1 millimeter line width, these dimensions have to be 51 by 51 to get the appropriate dimensions. That sort of the center of this line is the correct dimension, not the outer perimeter of this line. Just something to be mindful and aware of. So I'll set my first box there. I'll copy and paste. Control copy or whatever is in your thing, and I'll adjust my back portion to be 10 millimeters, or in this drawing, 11 millimeters. Now, a key thing that you'll need to do when you begin to assemble your drawing from these set of polygons is the easiest way to do it, is that alignment is always going to be the trickiest thing you'll need to do. Turning on this snapping helps you align to certain features. Here you can see sort of the outer bounding boxes are aligned with each other. We want to go from corner to corner, center of line to center of line. If you end up not having this on or it doesn't quite work, you're always able to go here to pull up this align tool and help you align objects to each other. We'll use that in 1 second. So looking at it, this is sort of our overall top view of our bracket at the moment. The overall dimensions should be from center of line to center of line should be 50 millimeters wide. This top section should be 10. And of course, with the other side overall should be 60 millimeters from corner to corner. Again, the actual sort of shape is slightly larger because of this line width, but we need to keep track of that ourselves. Now, our feature should also show any objects, any sort of features that are important to how this object exists in three-dimensional space. And the other missing feature are these holes as well as these sort of chair legs underneath our part. We don't quite see how far they go back, but we can make some guesses. So, just as we have before, we're going to try to figure out how big each of these holes are. And using sort of our general sort of estimation skills, we see that this is about, call it 11 millimeters across. If our original thing was 70 millimeters, at least as far as this drawing was concerned. That means that we'll get maybe 9 millimeters or so. This one, in sort of real dimensions, will be 12 or so. And we will also do some measuring here to get some dimensions, some putative dimensions. So we can also draw circles. Circles are drawn just as with squares. We can set the dimensions of those. Let's set those to be 8 millimeters whole, so it will be 9 by 9 millimeters. And we'll need 2 such holes, control copy to paste those. We'll also need to represent those hidden features, which we'll do in one moment. The other key feature that you'll want to use that sort of saves you some time is the ability to align using this alignment panel. Generally, we can do it a couple of ways. You'll need to select all the objects that you want to align with each other, and it gives you the option of which you want to align to first. You can do it based on which one you select, which one's biggest, so on and so forth. I want to align these circles to the center of this seat portion, which appears to be where these holes are located. And if I hit the center, it'll align on that vertical axis. I can align it to either side depending on what my drawing calls for, but here I can automatically snap them to the center. Now, in addition to aligning them relative to the midpoint of this seat, what we're going to do, or I'm going to do, is I'm going to align each of these holes to the far extreme. I'm going to put one on the bottom. I'm going to align one on the top so as to give them a translation point. Doing a sort of a quick measurement of sort of where these holes are relative, I can see that they're offset from, or rather from their edge. They're offset by less than less than a tenth of the distance. So I'm going to offset this. Now that they're aligned with the bottom, I can physically change what their dimension might be. So we're going to bump this up by 5 millimeters, which looks okay. It's probably a little less than that. So let's say we'll go by a good 10 millimeters on one side. And we can change the offset manually, giving us more precise control, exactly the distance between these two. You'll see that the amount that they shifted by from center to center, here about 10 millimeters distance. So one reason why we use these programs is it allows us to be very precise about the movements of each of these things, which is very, very helpful. The other two features that we have not yet drawn will be our hidden features. This hole is not quite visible from the top-down view, but we should still note that it is there as it helps align certain things, as well as these legs are not visible as well. When we want to show hidden features, a common convention is to use a dashed line to represent that structure or that object. In this particular case, for the sake of a little bit of clarity, we'll leave it as 1 millimeter. And we're going to reposition this to show the width of each of these legs. So we're going to modify some of these dimensions just as well. The height should be 61. And we'll make the width, just to sort of throw some different numbers in, rather than be 10 millimeters across, we'll make it 9 millimeters across. Just to sort of throw some different dimensions in there. With this, we'll align it once more. We're going to align it to the last selected object. Representing that these legs, as we've drawn them, go all the way back. Aligning those as well. So these dashed lines here show us that we have legs that are not visible, but they are features that are relevant to this top view. We can also include the presence of this hole by placing another dashed feature. In this case, this hole is a little larger than the 8 millimeters across that we sent. So we're going to make this, let's make this 12 millimeters across. And we notice that this hole isn't completely dug all the way through. It's still sort of showing this colored section here. So we're going to make it only a partial hole, which is an important feature to note from this top view projection. And we're going to make it go through half of that distance, so 6 millimeters or so, aligning once again to the bottom portion there. So we can see with this particular top view orthographic projection that we can see a lot of the features. We can get a better idea of the actual shape of this, which allowing us to make very precise measurements. Later in the videos, we'll show her how we label these dimensions using this program. And we can also see the hidden features overlaid on top, represented by these dashed lines. I'm going to continue to uh, generate some of these other viewpoints, and we'll pop back in together to show you some more tips and tricks for how we might use this program to build more complex shapes, things that are not just circles and squares.